So we'll now see about the ANSA introduction and also few concepts related to the graphic user interface. Okay, so okay, so first we'll be seeing about introduction to structural computer aided engineering, and under which we'll be seeing about the product development procedure. Generally, what is the product development procedure which will be followed in the industries will be seen, and what is computer aided engineering standard steps under this process. This will also be seen, and what are all the tools available for structural computer aided engineering. We'll see. Okay, so this will be our first module. Then second thing what we'll see is about the ANSA overview. Okay, so under this we'll be seeing about phases of ANSA, how to do the CAD setup, how to do the geometric handling of the components so that you are able to properly load those components in ANSA and do some geometry cleanup. Okay, so I'll tell you what is geometry cleanup and everything. And the next one would be the CAD topology and understanding the entities. And then we'll enter into the meshing part. So what are all the different meshes available for 1D, 2D, and 3D components, and how to mesh and how not to mesh. So in general, I can say that this will be mesh overview. Then we'll be seeing about the meshing process, which is more critical. Based upon this, whatever type of analysis you are going to choose, the answer will actually vary. So what are all the different meshing process and its effects on the components will be studied. So this will be our second module, and third one would be ANSA graphic user interface GUI. So how the software looks like and what are all the different options available and how to use that I'll show you. Okay. So you can also do the GUI customization. So customization in the sense, according to the user, they can modify the tools and keep it in a ready-made condition so that you can save some time. Okay. The next thing is how to do the view management. Then model management. Then about the CAD cleanup. Then how to do the surface meshing. Then after doing the mesh process, after doing the meshing, how to go for the quality check. You might have meshed, but how to check for the quality of that mesh. Then you will also get some hands-on experience through some projects. So this is what we are going to plan. So computer-aided engineering, basically, in the previous session itself, you might have seen, right? So it is actually a standard procedure which is used for any product development engineering department, from the point of design to virtual testing. Okay, so that is called product life cycle. Okay, so the most common type of simulations which are used in computer aided engineering actually includes, which we have already seen in the previous class, which is nothing but finite element analysis. The next one is computational fluid dynamics. The third one is thermal analysis. The fourth one is multi-body dynamics. And the fifth one is optimizations. Okay. So the basic aim of computer-aided engineering is to first generate the initial design. And then we try to simulate the CAD geometry. So this process is repeated until all the product requirements are met and virtually it is confirmed. Virtually in the sense because you are using a system, right? So you will follow that procedure.
Excuse me, sir.
Yeah, tell me.
What does simulate CAD geometry mean?
Simulation means you are going to make that particular component, whichever or product, whichever you have chosen for your analysis, and you are going to subject it to loading condition as well as boundary condition and real time animation. You will see how far the stress is distributed, how far the strain is distributed, and you will study about all the output parameters by simulating it. Simulation in the sense it will lead to an animation. Okay.
Okay.
So if you take the product development procedure, uh, first in the olden days we have this conventional procedure. So I'll tell you what is the conventional procedure. So first they will plan for a product and then they will design it and then they will create the prototype. Then they will go for the evaluation. Then they will go for the production. So after production and then they'll go for the testing, and if there is something which has to be redefined or modified, then again they will go back here. So the thing is, in olden days, if you are using the conventional procedure for product development, the procedure seems to be, it is not flexible, that you have to follow all these steps in order. And once for doing the final testing, you might find out some difficulties and then you will try to modify it. So modification here itself takes a longer duration of time and it incurs lot number of costs associated with it. So nowadays, with the advent of computer, we were now able to do it with the help of computer-aided engineering. Uh, this product development procedure has been made simple. So with the help of CAE, this has been now changed like this. We'll plan the same product. We will do the design where the CAD model and everything will be created. And then we'll immediately move on to the computer-aided engineering department where we'll check for the output parameters. Then and there, if you find any difficulties, you will go for the modification here itself. And then again, it comes to the prototype. And once after developing the prototype, you will again go for the evaluation of your product, like specifications and how to use it, how not to use it, and what are all the different limitations for it, everything. And then you will go for the production. So this saves lot of time and also the costs associated with each phase of product development cycle. So that's why computer-aided engineering is considered as very important. Okay. Now, if you take computer-aided engineering alone, there itself you have got three steps. The first one is pre-processing. Okay, so under pre-processing, you will be doing most of the steps related to simulation. So except simulation, you'll be doing most of the steps in pre-processing itself. So basically, pre-processing itself will cover the subdivisions of what I'm going to list out now. So basically, it will cover the CAD setup. CAD setup in the sense for any computer engineering department. In the previous session itself, I have said that the component would come from the CAD model department, right? So after receiving the component, immediately you can't go for the meshing and then apply the boundary condition and loading condition and then go for the analysis of the output parameters. You have to follow certain procedure. The first step is pre-processing, where you will actually go for the CAD setup, which is the first subdivision part. Under this, you will go for CAD geometry cleanup if there is necessary things to be done. Okay, so I'll tell you what is CAD geometry cleanup. See, basically, let's say for example, you are going to do some analysis on a particular component which was actually being modeled using CAD model department, and then you are receiving that file. You can't directly just like that go for the meshing and then do the next procedures to find out the simulation and find out the output parameters. First, what you have to do is you have to remove certain unwanted features which are given for aesthetic purpose, which are not at all going to be in the technical consideration. Those things has to be removed up first. So that is called as CAD geometry cleanup, which we'll see in detail while we are going to load some components in the ANSA software. I'll show you. So this step is very crucial, and this is the first primary step under the pre-processing. Okay, so you can also call this as model geometry cleanup. Okay, remove the unwanted features. Then comes the second step in this, which is called as under pre-processing only. I'm telling the second subdivision is your CAD modeling, where we will do the meshing process. So the meshing comes under preprocessor itself. You can say pre-processing or preprocessor. Then comes your third one, which is called as the boundary conditions. Boundary conditions setup, under which you will also see about the load cases. Say in the previous example itself, if you have taken a cantilever beam, you know that this end of the beam is being completely arrested, fixed. So I can say that all the 6 degrees of freedom has been completely arrested. Okay, so there is no movement at this left extreme support. So that falls under this category, boundary conditions. Okay, so all these are actually coming under the pre-processor step itself. Okay, so what are all the next few steps which are available under computer-aided engineering? The first step is pre-processing. Under that subdivisions, you have got 3. And the second one is solving. Once after doing all the pre-processing work, then you will go for the solving. Then the third step is nothing but your post-processing. So post-processing generally involves after you are simulating in the sense I already said that it is nothing but the animation. So after doing the animation and finding out the output parameters, you will actually go and use those results to give a plot in the sense you can just plot it in the graphical format, and then you will study about that. So those kind of things and the inference which you are going to understand by the simulation of that component will be studied everything under the post-processing step. So basically computer-aided engineering involves 3 main steps. One is pre-processing, the second one is solving, and third one is post-processing. Solving is nothing but you are just going to choose some solver to solve your problem. Okay, just like a calculator, you have n number of models in it, right? Which model you are going to choose to solve your problem. So that is nothing but you're solving. Post-processing is something that you have got the results in the animated format and how you are going to transfer those results into graphical format or plot format or any other format which you want. Okay, so those are nothing but the post-processing part. Okay, till this it is clear, right?
Yes, sir.
Okay, fine. Now we'll see some of the softwares which has been actually being used for as a tool for structural CAE. So for computer data engineering, These are all the preprocessor. Generally, what we'll be using. So preprocessor is the one where you will do up to the meshing process, and then you will also decide about the boundary conditions. Okay. So one such software is nothing but the software which you have chosen, which is ANSA. The second one is Hypermesh. Under preprocessor, you have got these two. Then for solving, I said no. What type of calculator you are going to choose? For solving, you have got n number of solvers, out of which the popular ones are Abacus, Nastron, LS Dyna. So ANSA itself is a preprocessor. It does not contain any solver. But you know what? This is a separate software. This is a separate software. This is a separate software. So ANSA includes all these solver modules in it, so that you can solve using these calculators. Okay. The last step is post-processor. For doing post-processor also, you require a separate window. Okay. Or I can say a separate workspace. Okay. So for which you will have these popular thing. One is MetaPost and the next one is Hyperview. See, Hyperview is actually a post-processor window which is being used in this software, Hypermesh. But you can tell me that then Hypermesh is also a preprocessor. It does not contain post-processor. No, it has got, but it has got at its separate, separate space. So in general, totally you can call that as HyperWorks. Under HyperWorks, you have got this Hypermesh, which is used for preprocessor. And then you also have got few solvers like OptiStruct, Radios. So these are all everything available in the HyperWorks itself. Okay. But it has got a separate space for each and everything. Okay. Now our aim is to look on for the ANSA. Okay, so I'll give you an introduction about ANSA, then we can go for the graphic user interface. So ANSA as a software, it has been developed by the Vita CAE systems. So it is basically a tool which has been used for finite element analysis and also computational fluid dynamic analysis. And it is widely used in automotive industry. Okay, so and it also carries proprietary algorithms. So basically you are giving some information to the software. Using the software, you will use some tools, but the software has to understand in its own way. So there are some algorithms which has been set for meshing. For doing proper meshing for your components, certain algorithms have been pre-fed inside this software. Okay. So this full form of ANSA is nothing but automatic net generation for structural analysis. But you might wonder that it is suitable only for structural analysis. No, it was actually started in this name. Now it has gone beyond that. Okay, so you can do other works also using ANSA. Basically, it was started as a preprocessor. Later, they have also bought up a few of the solver modules and then integrated with ANSA. Now you are able to solve those models also rather than just by pre-meshing. And also it has been developed for the structural analysis, but now it has now gone beyond that. Okay. So these are all the basic idea. So the next thing is the phases involved in ANSA. Yeah, tell me. So these are all the different phases involved with ANSA. First thing, you will actually start with the import of CAD geometry. So which means whatever component you are going to do the analysis work, you are not going to create that using ANSA, because ANSA is actually a, if it is a computer aided engineering software where you can do the analysis at its best, but you cannot create the geometry. It's a simple geometry means it is okay, but if it is a complex geometry, you have got own softwares for that, like SolidWorks, Creo, CATIA, where you can use those tools to create your CAD geometry. Once after creating that CAD geometry, you're going to import that to ANSA. Then, as I said, that the second most important step, what you will do is the geometry cleanup. Those imported CAD geometry will also have some certain errors, and also certain features has to be removed. So, because that might be given for some aesthetic purpose. So, the second most important thing what you will do under ANSA phases is geometry cleanup. Then the third one, what you'll do is you might require to extract the skin or mid-surface generation. I'll tell you what is this step. See, basically you have got three types of board components. One is 1D component, another one is 2D component, another one is 3D component. While doing meshing for the 2D component, you have to definitely do this step, which means you have to extract the mid surface. I'll tell you just in a few seconds after finishing this ANSA phase. Then the fourth step, what we'll be seeing is we might go for shell or solid meshing. See, if you know your component is 3D, then you will do the solid meshing. So for 3D components, you will do the solid meshing, or it is otherwise called as volume meshing. If it is a shell meshing, then it means that you are dealing with 2D components. Then after doing the meshing work, you will do the element quality check. Then if you find that your meshing is not good after doing this step of element quality check, then what you will do is you will try to re-improvise. Okay. So after doing the meshing, you will go for element quality check. Then after that, you will go for the mesh improvement. If certain elements have to be removed, then it has to be removed and replaced with some good meshed elements. Then the next thing is finally you will go for the apply of your load and boundary conditions, BCs. Then after that, you will go and solve that, and then you will export your file. So this is a procedure that you will generally follow in the ANSA phases. Okay. Then if you remember in the preprocessor, I have said about the CAD setup. So in the CAD setup, you will have certain formats. Formats for actually, for importing that inside the ANSA software. So ANSA generally supports generic CAD formats. See, imagine that you are doing some component modeling using SolidWorks, Creo, or CATIA, any software. You might be familiar with this file extension .prt, which is nothing but part file. If you save the file in this format and then try to export it to ANSA software and try to open it, it will not open. Because this works under a different graphic standard, whereas this CAE software works under a different graphic standard. So if you want your component to export to ANSA and open it without any problem and work on it, then you have to follow these generic CAD formats. So one such basic format is STEP, which is very popular. So whenever you are doing some component modeling using SolidWorks, Creo, or CATIA software, you are going to save that file in this format, STEP or IGES or STL. These two are very much famous. Okay. So this might look like .step, or sometimes it should look like .stp. Okay. And similarly, this would be like IGES itself, or in small letters IGES, or sometimes like IGS. Everything was one and the same. Okay. Similarly, this is .stl. So this you have to keep in your mind that whenever you save a file, then you have to go for this. Then the
Okay.
next one is, yeah, tell me.
No, okay, sir.
Okay. So the next one is model dimension. See, before doing any analysis and before entering into the meshing, you have to keep the dimensions of the model, yeah, under which unit system it is being. So that has to be followed in the CAE analysis also. So the dimension of model will be very important for simulation setup. Which means whether your model is being created using meter or or inch will have a huge impact on your results if you don't consider that properly. Okay. Then comes your geometry editing. See, under this geometry editing, already I said that you might require to do some surface patch-up works. Certain surfaces may not look like a good one, or it is not a good closed one. In that case, then you have to do some surface patch-up, or you might also call that as creating new surfaces, replacing the old surfaces by new surfaces. So these you will do using the geometry editing part. Okay. Then you might also require to
Excuse
remove
me,
some
sir.
yeah.
The geometry editing, we can do that in the ANSA software?
Yeah, you can do it in the software itself.
Ah, okay. So we don't have to go back to a CAD
No,
software,
no, 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 no,
edit
no,
it,
no,
and then
no, no,
come
no.
back
You will
again.
do it here itself. Once when you receive the
Ah, okay.
component here, then you can start doing that here itself. Okay. So
Okay.
basically, I was
Okay.
telling you about defeaturing. You might require to do this step of defeaturing. So basically, feature means I can say that fillet, chamfers. These are all the examples for features. There might be something which you have to defeature while before doing meshing. So I can say that we have to remove unnecessary surface radius. Imagine you are dealing with a 2D component where there is a huge curvature of a surface which you have to remove because without removing that, it will be very hard for you to go for the meshing process. Then you might remove some pinholes. We'll be discussing that in detail in the upcoming sessions. Then you might also remove some edges. Often your CAD model actually have many detailed features because of the manufacturing constraints or the installation. But you have to remove that while doing the meshing process. So that is called as defeaturing. There might be some
So
sharp
removing,
angles also required. Huh?
is it okay to remove these and do the analysis?
Yeah,
Won't
yeah,
they
yeah. Yes,
affect the
yes, yes. That
analysis?
I'll show you. I'll show you. I'll show you. Don't worry. Okay. Now remember and keep in your
Okay.
mind that you have to defeature certain things, and these are the defeatures which we'll generally encounter before doing meshing of any of the components. Okay. We might deal with
Okay.
some larger surface area. We might deal with pinholes, very very small holes. Okay. Pinholes means very small
Okay.
holes, very small hole diameters, and few of the edges which also have you know very minute radius and sharp angles. These are all the things which
Okay.
actually make your meshing to fail. your meshing process to fail. Without meshing, then you will not be able to apply the boundary condition and loading condition to find out the results, right? So you have to get rid of all these things before entering into the meshing part. So already I have defined you about the mesh. What is mesh, what is node, and everything in the previous session. Now I'll tell you what is the 1D component, 2D component, and 3D component. See, 1D component is a one where the length is very, very large when compared to the other dimensions. So basically everything is 3D, but you will actually change that 3D into a 1D component based upon your understanding. For that understanding, I'm giving you a clue that if your length of the component is very large when compared to other dimensions, then I can regard that as 1D component. I'll give you an example. Let's take a beam, the same cantilever beam. Okay. If I see through here, then let us assume the cross section is circular. Okay. Or else let me draw a diagram, something like this. So this is your x-axis, this is your y-axis, and this is your z-axis. Now imagine that I have a length of the beam as 1000 mm. And let's assume that my diameter is 100 mm. So which means along this axis also it is radius or diameter. Along this axis also it is radius or diameter. But along this axis, z-axis, I have the length, right?
Yes.
Now you compare this 100 with 1000. It is almost 1:10, right?
Yes.
Then we'll regard this beam as 1D component. This actually will make you a professional because everything is 3D only. But the thing is, if you do the 3D meshing for all the components, then why you need to do all these things is, see, unnecessarily if you are creating a 3D mesh for all the components, then you are actually increasing the computational time. Computational time in the sense, after you click on the solve button, you might have to wait for 2 to 3 hours for solving a beam problem, because you have given 3D mesh. Instead, if you can regard that as 1D and do the mesh, you can finish it off in seconds. And if you solve, immediately the answer will pop up. But both the cases will give you the same answer. That is the beauty. Which means you should be able to understand what is 1D component. All those which have the length very, very large when compared to the other dimensions. So I have given beam as an example. You can even consider columns, right? Columns are the vertical ones where also you can find out your length is very, very large. And I'll give you one more example, which are shafts. Lengthier shafts are the one which has very large length when compared to the lateral dimensions, correct? Then comes the 2D component. In this also, you will regard, you will have two dimensions comparable when compared to the third dimension, so that you are neglecting the third dimension. Usually the neglected third dimension would be thickness. So I'll show you an example. So this is where you deal with the surface and sheet metal parts. Just few minutes before, we have been seeing that you will be dealing with shell meshing and all. So shell meshing is associated with 2D, I said, right? So that is because you are dealing with surface or sheet metal. So I'll explain you how. So let's consider a flat plate. Imagine that this is the length, which is, let's say, 500, and imagine the breadth, which is, say, 300, and imagine the thickness is 10 mm. Now compared to your length and breadth, your thickness is negligible because it is just 10 mm. Now you will convert this into a 2D component. You will consider this as a 2D component where you are neglecting the thickness, since the thickness is very, very negligible when compared to these two dimensions. Okay, so this is a very crucial part, so that again you don't increase your computational time by doing the volume mesh or 3D mesh over this component. Instead, you will go for the shell mesh. Then comes the last one, which is the 3D, where all the three dimensions are comparable, nothing is negligible. Like for example, if you take a cube, if you take the cube, then you know that all the three dimensions are one and the same. Nothing can be neglected in this, right? This dimension, and even this dimension. All the three are equal, in fact. Okay, you can't neglect. In this case, you don't have any other go. You have to do the volume mesh. But don't do the volume mesh for this category. Don't do the volume mesh for this category. You have got separate techniques for that.
So how do you determine if the other dimensions are negligible? I mean, it's much less, but how do you know for sure?
You
Uh,
have the CAD model in your hand before doing the analysis, right? And also you know the name
okay,
of that because you might be reading about this in your undergraduate program itself, right? Like beams, columns,
okay,
shafts, all these are known terms only,
right,
like plates.
okay,
Where your thickness is negligible, then I can make this as 2D component. Where your length is very, very
okay,
large, definitely I can make that as 1D component. Okay. So once when you are used up to all these types of components, then you'll know this is a 1D category, this is a 2D category. Most probably you'll be dealing with 2D category and 3D category. 3D is not at all a category.
right,
You're considering all the dimensions, that's all.
okay, okay,
Okay. So that's very important. Then I'll show you something where I have I have prepared for you this thing about the graphic user interface which you will follow in the software. These many options are
okay,
available in ANSA software. Okay. And I have included this figures also so that you understand that in a better way. Anyway, I'm going to
okay,
explain you and I'm going to give the
okay,
video backup. But still, if you have this handout with you, then it will be very easy for you to understand because you have to be used up to all these kind of tools. What is that tool is, how to use that, how not to use that, what are all the different sub options available for each and every case, and see, it runs for pages.
okay,
So this I will forward you, and in the next class we will be opening the ANSA software, and I'll be explaining you
okay,
about the graphic user interface and everything in detail.
okay,
Then we will
okay,
move on to the component part. Components, while I'm teaching you, I'll forward that component. You can make use of that component itself, to practice. Okay, and I'll also give some project works also as we further move upon.
okay,
But these are given as if you are our student. Okay, do not circulate these components to your friends or anyone. Okay,
okay, okay,
done. So thank you. I'll forward this video to you. Okay.
okay, okay. Thank you very much, sir. Good night.
Tomorrow also night time only. Okay, 8:30. Is that fine with you?
8:30. Yeah, that's okay.
Okay, fine. Done. Thank
Okay,
you.
thank you.